Welcome to Unit 4, Lesson 1 on relations and functions. In this lesson, you will be learning how to identify functions. You will be learning about what a function is and how it's different from a relation. And you will be finding the domain and the range of relations and functions. So we're going to start out with some vocabulary. The first section of every new unit always has a lot of new vocabulary words, so we need to go ahead and define what those words mean. So first of all, a relation is just a set of ordered pairs. It's any relationship between two things, whereas a function is a special type of relation where there's exactly one output for every input. And I think this will make more sense for functions when we get into some more graphical representations. There's a number of ways that we can represent relations and functions. One of the ways that you'll see is just as a set of ordered pairs. So I have an example at the bottom of the page here. If we just have a set of ordered pairs, that represents a relation. Or we could represent them by a graph. Okay, if we actually graphed those ordered pairs, that's another way to represent a relation. Or a mapping diagram. When you see two sets with some arrows like this, that's called a mapping diagram. We could represent them by a table of values, or we could also represent by an equation. Now, some of these representations are relations. Well, they're all relations, but some of them are functions and some of them are not. So let's take a look a little more closely at some other vocabulary words you will need to know. One of them is the domain. When we talk about the domain, we're talking about the inputs of the relation or function, and those are always the first numbers or the x values. The range then is the outputs, which are the y values or the last numbers. So let's look at an example. This example says, express the relation for the track meet scoring system, and here's a set of data. They want us to express that as a table, a graph, and a mapping diagram, and then we want to identify the domain and the range. Well, we said that the domain is the first numbers and the range is the second numbers, the y values. So let's set that up as a table to start with. If we were to write that as a table, we would take all of the inputs, okay, those would be the first values, 1, 2, 3, and 4. Those are the x values. And then the outputs, or the points, are the y values. Okay, so there's that representation as a table. The representation that was given to us was as a set or a set of ordered pairs. So if we were to graph each of those ordered pairs, it would look like this. So there's another representation. And then as a mapping diagram, it would look like this. Okay, the inputs and the outputs. Now the domain then is the set of all the inputs, 1, 2, 3, and 4. And the range is the set of outputs, 5, 3, 2, and 1. So pretty straightforward, nothing too difficult there. So another thing you need to know as far as vocabulary goes, and we've talked about this, is whether or not a representation is continuous or discrete, whether the graphs are continuous or discrete. Continuous graphs have no breaks or holes in them. They're smooth curves, whereas a discrete graph, those are just individual points that are not connected. So I've got some examples here that would make hopefully this a little more clear. Letter A demonstrates a heart rate over time. Well, a heart rate generally doesn't stop. Okay, this is someone's heart rate that is alive. So that represents a continuous graph. Okay, it goes on and there's no breaks. It's a smooth curve. Whereas the earnings that you make, okay, you don't make money in between the hours that you work, in this graph anyway. So these are specific hours. If he worked 1 hour, that's what he earned, 2 hours, 3. So those are just individual points, and that is a discrete graph. And then letter C, it says Jamie's taking an 8-week keyboarding class, and at the end of each week she takes a test to find the number of words that she can type per minute. She improves each week. So she's getting results at the end of the week. She's not doing it continuously, she's doing it at set points. So that would also be an example of a discrete graph. So to determine whether or not something is a function or relation, Well, one of the ways that we do determine if a graph represents a function is to use what we call a vertical line test. And when we use this vertical line test, if that vertical line, if the graph we're testing crosses that vertical line exactly once, then it is a function. However, if the graph crosses a vertical line more than once, it is not a function. So let me show you what I mean by that. I have a couple of graphs down here, and we're going to just take a vertical line, and I'm going to grab this thing, and if you look at this, anywhere I place this, no matter where I place it, it will only cross that vertical line once. There's only one point at any point in time here. We can never make it cross more than once on any vertical line. Okay, so that one definitely is a function. Well, let's look at the second one. This one, well, there you have, it's already crossing twice, that vertical line, so this is not a function. How about the third one? If we take a vertical line on the third one, looks like that one's only going to cross once no matter what we do, so that one is definitely a function. And finally, the last one, you can see that if I put it over here to the left, it only crosses once, but once I get over into this area, we've got it crossing 3 times. So that's definitely not a function. So that's one of the ways to determine if something is or is not a function. To determine if a relation is a function, we want to state the domain and the range. Okay, so in this example, when we're looking at the domain, okay, we have 4 different items in the domain, and each one goes to one place in the range. So this one is definitely a function. And I don't think I have that written in here, so I'll go ahead and write it for you. So this one is a function. Now letter B, if you draw the vertical line, right, we can see that that crosses twice. So that one is not a function. Okay, so the domain on this one is 6, 5, 2, and 1. This is actually the domain, and this one is the range, right? The domain on letter B, and I thought I had this in here. Let me just check. No, I don't have it in there. So the domain on letter B, okay, is going to be all the values. If you look at the domain, this value right here, we go -1, -2, -3, -4. They're always the x values, right? So it goes from -4, these are x values, all the way to +4. Whereas the range on this one, the range are the y values, and that goes all the way as well from -4, and these are y values, all the way to 4. So that's how you would write that. The y values are less than or equal to 4, but greater than or equal to -4. Same for the domain. Okay, what about over on letter C? The domain for this one would be all of the values that are given right here, 1, 4, and 8. So we just write that as 1, 4, and 8. And you put them in those curly brackets. And then the range would be 1 and 4. We don't have to list it more than once. Once we list it, even though 1 appears twice, we only have to list it in the range once. Okay, in this one, every single thing in the domain goes to a unique thing in the range, so we don't have anything going to the same place. So this one is definitely a function. Okay, as long as you have different values in your domain, if they're all different, it's a function. So look at this one. We have all different values in our domain. So the domain would be all of these values right here. Okay, and the range is going to be these values. Okay, so this one is also a function. All right, so this one is for you to do. Go ahead and determine if it's a function. State the domain and the range, whether it is or isn't a function, but go ahead and write what your domain and range are for each of those relations that are given. We'll check those when you come to class. And that is going to do it for this video. We'll see you in class where we'll do some more practice. See ya.